Uncertainties in the calculation of the lifetime of superheated steam pipes in power plants that contain a minor defect create situations with potentially catastrophic results, typically costing €120 million per event. Superheated steam pipes are periodically inspected, and depending on their defect sizes, they may be replaced after a lifetime assessment has been performed. Common errors in defect sizing create dangerous situations, as size underestimation will result in a pipe prone to failure. Innotec and Encon often face this difficult issue when performing inspections for their customers, thus the need for a frequent in-service and accurate monitoring of defects on pipes was identified. The final goal of the Hot Phased Array project is the development of a structural health monitoring system for superheated steam pipes. The expected benefits of the project are increased safety in electrical production power plants, elimination of catastrophic accidents from superheated steam pipe failures, decrease of the required shutdown time for inspection purposes, increase in confidence in the operational safety of thermal power and nuclear energy plants. Advanced ultrasonic techniques such as phased array on time-of-flight diffraction configuration can be used to detect and monitor defects at ambient temperature. However, at high temperature operating conditions, this technique cannot be applied due to lack of availability of high temperature probes for operation at temperatures up to 580 degrees Celsius in electrical power plants. The key challenge is to develop high temperature phased array on Toft probes for continuous monitoring of defect growth over time. The high temperature structural health monitoring system concept consists of the following key components: high temperature phased array on Toft probes, ruggedized phased array pulsar receiver unit, and signal processing and visualization software. A number of different organisations from all across Europe and further have been involved in the development of high-temperature structural health monitoring system. Brunel University from England and Vermont from France have been developing the high-temperature probes. I Know How from Greece and Innotec UK from England have worked on the pulsar receiver unit and software, whilst leading small and medium enterprises have been Encon from Turkey, Technitest from Spain and Innotec from Croatia, where Innotec also successfully coordinated the project.
Here we have the hot phased array setup. We have the pipe, which is representing the pipe on the power plant. We have the two wedges made in steel, stainless steel in this case, and the two probes, representing the two probes in Toft configuration. We have the coupling underneath for bringing the sound into the pipe. We have the two probes connected through a splitter box into the instrumentation which will be deployed on the site. And then on the instrumentation itself we have the software. Go over the software. On the one hand, on the left hand side we have the viewing area, so this is where the phased array Toft method is going to be displayed, so the signal amplitudes from the different positions inside the metal. We put in the parameters for the system. In this case they're all arranged in tabs on this side of the system. And when the parameters are set up, we start the system to scan.
Some initial tests of our phased array transducer that was developed within Hot Phased Array project will be done with a standard UT set, an oven and a steel carbon block where we achieve the temperature of 150 degrees on the surface of the block. So I have a high temperature couplant that I apply on the surface of the block. I take my transducer in a glove to protect my hands from the heat. I put the transducer collect the data.